What do you need in order to subtract fractions? You need a common denominator, right? Now, it's been a while since you learned how to add fractions, and it's been even longer. Well, it's probably been a long time since you've like thought about how you add fractions. Okay? Um, so I'm going to talk to you about these the way I need you to know to talk about these. Is that fair? Okay. So what we need to add fractions is a common denominator. You said that already, right? Well, do these two fractions have a common denominator already? So what do I do to add them? Are you sure? So I don't say 5 over 14? No, I don't, right? Once I have a common denominator, that's my denominator. It stays, and I just add the numerators. Okay, so what steps did I take to get there? So first of all, we looked for a common denominator. And then exactly like you said, then we added the numerators, right? So if we're doing a rational expression problem, do these two fractions have a common denominator? Yes, so I leave it. What do I do with the numerators? I add them. So that's what I was afraid you would say. What do you get when you add 2 and x? Guys, that's what you get when you multiply 2 and x, right? If you're adding 2 and x, you get 2 plus x. Okay, so be careful with that. Now, this was a conversation earlier. Which one of these is correct? They both are, right? This one makes more sense logically in what we did, like what we're doing. 2 plus x is 2 plus x, right? Why do some people want to write this way, though? Because the x comes first. We like to have the x come first, right? We like to have the variable come first when we're writing, but there's nothing wrong with either one of these as answers. They are both correct. Does that make sense? Okay, and now I can cancel the x's, right? No, because that would be ridiculous. Remember that? Remember us having this conversation? This would be ridiculous because that would be like 17 over 19. You guys remember that example I showed you? Yeah? Okay. So this is just our answer. We're done, right? It's our solution. Okay. What about this problem? What do you notice? It already has a common denominator. Good. So what do I do with the numerators? Just add 2x plus 5x. Negative 3 plus 7 plus 4. Done. Any questions? You got it okay? Okay, let's look at the next section then. How is this problem different than what we just did? Oh, it's subtraction. Okay, that's good to notice. What do I need in order to subtract fractions? Oh, still a common denominator? Okay, so, oh, it already has one. So what do I do with the numerators? Subtract, right? What's 8 minus 3? 5. So we looked for a common denominator. Oh, geez Louise. I don't know why I wrote past tense on this one, sorry, because that's what we did. This is what I want you to do. I want you to look for a common denominator. And then we subtract numerators. Does it matter what order you add in? No, that's why we can say this, right? We can say 2 plus x is x plus 2, right? Does it matter what order you subtract in? Is 8 minus 3 the same thing as 3 minus 8? No, it's not. So it does matter what order we subtract in, right? So just be careful of that. What do you notice? It's already common, so I keep it. And what do I do with the numerator? Subtract. This is where I need you to be careful, okay? Because I can't tell you how many people are going to say the answer is x plus 20. Why are they going to say x plus 20? Because it's 2x minus x. That's x. That's easy to see, right? And then we have 11 and 9. That's 20, right? No, it's not. Not at all, right? Because we are subtracting 11 minus 9. So you have to remember to subtract every term in the second one. We're subtracting everything over here, not just the first term. Got it? And now we cancel out the x's? Okay, good. Of course not, because that would be ridiculous. Okay? All right, what about this one? Already common, so I leave it alone. And then x minus 9x. 3 minus negative 7 plus 10. We good? Okay. Uh-oh. What's rule number 1? What's rule number 1 always? Don't panic, right? Just because it doesn't have a common denominator doesn't mean we automatically panic. There are times when it's time to panic. It doesn't have anything to do with math. It has to do with like zombies and dragons and things like that. Okay? And what? And what? Baseball bats? No? Okay. What about now? Are they common? So I have to find a common denominator, right? So far the most popular incorrect answer for what is the common denominator is 4. That's the most common incorrect answer. Okay? Now I agree that both of these numbers divide by 4. I agree with that. Okay? But the thing is that our common denominator has to be at least as big as the biggest number, if not bigger. It's not what they divide by, it's what they both divide into. So what do both of these numbers divide into? 8. If it's got to be at least as big as the biggest one, you got to start with 8, right? Another way to look at this is 4 times 2, right? Isn't that what 8 is? Well, now they both have a 4. Teachers and students, please pardon this interruption. At this time, please release all varsity softball players to the locker room. Thank you. They both have a 4, but this one has something extra. If this has something extra, this one needs that something extra. So that's another way to think about that we need to get it to 8. Does that make sense? So if the new problem has a common denominator of 8, this one used to be an 8 and now it's an 8. So what happens to the numerator? It used to be a 3, now it's a 3, right? It stays. This one used to be a 4 and now it's an 8. What do I have to multiply 4 by to make it become an 8? A 2. So what do I have to multiply the numerator by? Also 2. Please remember, and I know this is just a remember, I know this is not me saying this for the first time to you or somebody saying for the first time to you. We don't ever add or subtract anything to get from a denominator to a new denominator. You know that, right? It's always we're multiplying by something to get to the new denominator, yes? Okay. Now that I have a common denominator, what do I do? Yeah, just like we did up here, right? Look, okay, we have a common denominator, it's 8. 3 plus 2. That took entirely too long. You're scaring me today. So what did I do first? Yeah, I have to find a common denominator first, right? Once I find a common denominator, we're going to add or subtract numerators. Now I know in this particular problem it's just add, but I also know in these examples I've got one add and one subtract, so that's why I wrote add or subtract. Is that fair? Okay. Because we know at this point the steps are the same, right? All right, so look at this problem right here. What do you think the common denominator is? So what do you think is the most popular incorrect guess of a common denominator? X, right? That's the most common incorrect answer because they both have an X. I'm so glad that you can see that they both have an X because you know that has to be part of the common denominator, right? But what does this one have that this one doesn't? a 3, then this one also needs a 3 for it to be common. Does that make sense? So I'm going to rewrite my problem. When I get my common denominator, we say it's 3x. This one was a 3x, and now it's a 3x, so what happens to its numerator? It stays, right? What does this one need to be multiplied by to make it become, yeah, so it's 3. So I have to multiply the numerator also by 3, don't I? So what does this new numerator become? 3x plus 3, right? Because I have to distribute that 3 to every part of the numerator, don't I? And now that I have a common denominator, I can just add my numerators. And what do I get? And now? Oh, I'm done. You don't want to cancel the 3x's? Okay, good. What about this example? This one's not necessarily as easy to see. If you're a visual learner, it's not necessarily as easy to see. But it would be easy to see if I had this denominator right here and I factored out a 2 from each term. Now is it easier to see? Do they both have an x plus 2? Then that for sure has to be part of the denominator, but this one has an extra 2 as a multiplier, right? So what does this one need? It needs that extra 2, right? So what is my common denominator going to be? 2 times x plus 2. Is it okay if I leave it factored? Is that all right with you if I leave it factored? Yeah? Okay. Sometimes it'll make a difference, sometimes it won't, but I don't know that one way or the other right now, so I'm just going to leave it for now. And I'll show you what I mean in just a second. Okay? So this one was 2 times x plus 2. Now it's 2 times x plus 2, so the numerator stays the same as well. This one was x plus 2, and now it's 2 times x plus 2. So I've got to multiply both numerator and denominator by a 2, right? So what does this numerator become? 18, right? Because 2 times 9, 18. Yeah? So now what do I have left to do? So 2 times x plus 2, x minus 17. Good with that? Any questions so far? Then there has to be questions like this. Here it was easy to see. This one had they both already have a 4. I just needed to multiply this one by a 2 and this one by a 2, right? Or between 8 and 4, we can tell that it's 8 because they both divide equally into 8, right? This one, they don't even have any common factors at all, right? What'd you say? Why? And how did you get 35? So you just multiplied them together? When in doubt, you can get a common denominator by just multiplying them together. Okay? Even in the case like this, I can just multiply them together and get 32. And I could use that as my denominator, right? Now, it's going to turn out to be not the least common denominator. So I'll have to simplify in order to get my answer, but I can still get my answer that way. Okay? But in a case like this where there's not any common factors at all, the only way I can get my common factor is, or my common denominator is by multiplying them together. Okay? So this one used to be a 7 and now it's a 35. So what do I have to multiply that by to get it become 35? 5. So I have to multiply the numerator by 5 as well, right? What's 5 times 3? 15. This used to be a 5 and now it's a 35. What do I have to multiply by? 7, okay. 7 here and 7 here, right? We got to remember to multiply numerator and denominator by 7 or I've changed the problem, right? So what is this? 14. Now that I have a common denominator, what do I do? Okay, do it. 29 over 35. So I find a common denominator. And then I add or subtract numerators. Okay, you ready to try rational expressions? Okay. What do you think my common denominator is? 3x. When in doubt, multiply them together, right? So this becomes 3x minus something over 3x, right? Something over 3x minus something over 3x. So what does this one need? A 3. So the numerator needs a 3 as well, right? What does this one need? An x. So this one needs to multiply it by an x as well. So this fraction is 3 times 5, which is 15. And this fraction is 2x times x, which is 2x squared. Now that I have a common denominator, I just add or subtract the numerators. 15 minus x squared. Oh, excuse me, I forgot the 2. 2x squared. You good with that? Any questions about that? Oh, okay, so you want to write it as, let me see, negative 2x squared plus 15? That's what you want to write it as? Is that okay? Yeah, absolutely. Yeah. Some people don't like to write it this way because if you write it this way, there's really only one sign, right? But if you write it this way, you have to remember to keep the negative with the 2x squared, and then you have another whole sign that you have to keep track of. But either one of them are correct. Just like we talked about right up here, either one of those are correct. Is that fair? Okay. Again, some people like to write it this way because the variable's first, right? Doesn't matter. It's the same. Okay. All right, last one right here. What's the common denominator? When in doubt, multiply them together. That's a 2. So x plus 3 times 2x minus 1. All right, what does this one need? It needs a 2x minus 1, right? If I multiply the denominator by that, I have to multiply the numerator by that. So what does that one become? Yeah, absolutely. 8x minus 4. Okay. What does this one need? An x plus 3. If I multiply the denominator by that, I have to multiply the numerator by that. Very good. Once I have a common denominator, I just combine the numerators. 8x plus 7x. Good. Negative 4 plus 21. 17. Any questions? Okay. Go please to number 5. Do you see number 5? Add or subtract each set of rational expressions by finding a common denominator. Hint, it may help to factor the denominators first. Isn't that what we did on this one over here? We factored the denominator first so we could see stuff they had in common. Yeah? So let's factor these denominators. Can I do anything to this denominator? No. Can I do anything to this denominator? Oh, yeah. What do you notice about this? It's the difference of squares, right? What does it look like if I factor it? X plus 2 and x minus 2, right? So what do you notice about this? Don't they both already have an x plus 2? Then that for sure has to be part of the denominator, right? What else does this one have? Then that also has to be part of the denominator. Does this one have something extra? No, just this one. So I got to have that part there too. You okay with that? All right, so what does this one need? An x minus 2, right? So top and bottom, numerator and denominator gets multiplied by x minus 2. So 2x squared minus 4x. You okay with that? And then what does this one need? Oh, it doesn't need anything? It's already exactly the same, right? So the numerator stays the same as well. Once I have a common denominator, add the numerators. So basically now I'm just combining like terms, right? So 2x squared, negative 4x plus x, negative 3x, and then minus 11. Now, this time I'm done. Sometimes I'm not, okay? Because sometimes this numerator can be factored, right? I'm trying to save us a little bit of time right here by hoping that you'll trust me that it's done, okay? But just in case you don't trust me, which is fine, 2 times negative 11 AC is negative 22, right? What two numbers multiply to be negative 22 and add to be negative 3? Nothing, right? So I can't factor this. What if I could factor this and one of the factors was x plus 2? What if I had a factor of x plus 2 in the numerator and a factor of x plus 2 in the denominator? What could I do? Yeah, that simplifies to 1, doesn't it? I could cancel those out. And I would have whatever was left over x minus 2, right? Remember when we talked about removable discontinuities, we found the factors in the numerator and the denominator that were the same, and that's where there was a hole? That's the same kind of thing I want you to think about right here. We got to factor this out. Excuse me, factor this out. See if there's any common factors in the numerator and denominator. This time there's not. There doesn't happen to be, but that's a possibility. Okay. Look at number 6. So the further we go, the messier it's getting, right? I mean, I could stop right now, but then you still have problems like this in your homework. So I think I won't stop. Okay. So what did we say was our hint? What should we do first? Factor the denominators. Okay. So what are the factors here of this denominator? X plus 3, x plus 4. And can I factor this denominator? Oh, they're both divisible by 2, aren't they? So I could factor out a 2 and get x plus 4. That's nice, isn't it? Because what do you notice? They both have an x plus 4. So that for sure is part of my denominator. What else is left? A 2 and an x plus 3. So both of those have to be part of my denominator because they were both part of the original denominator, right? Do I have to write x plus 4 twice? Because it happens here and here. I don't. I can. That will make it harder later. I'll have to simplify. So if it happens like in each denominator, I only have to list that once. You okay with that? So my denominator is 2 times x plus 4 times x plus 3. Okay? All right, so what does this denominator need to get to here? A 2. So if I multiply the denominator by it, I have to multiply the numerator by it, right? What is our new numerator for the first fraction? Perfect. What does this one need to get from here to here? An x plus 3, right? If I multiply denominator by it, I have to multiply numerator by it. What does this new numerator become? So once I have my common denominator, which is 2 times x plus 4 times x plus 3, what do I do with the numerators? Combine, right? I'm subtracting those, so keep that in mind. So 2x minus 5x, negative 3x, and then 12 minus 15. Exactly right, minus 3. Okay? Now, this one's a little closer to being able to simplify, because think about this. What would I get if I factor it out of negative 3? X plus 1, right? Now, that's close to x plus 4 and x plus 3, but x plus 1 and none of these will simplify. So do I have to factor my numerator every time? Like writing it out? I don't, but I probably need to think about it in my head, right? Because if this was a 12 and I factored out a negative 3, I would get an x plus 4, right? And I could simplify from there. But this is a perfectly fine answer as long as it's simplified all the way. Does that make sense? Okay? All right, one more example. Number 7. What should I do first? Factor the denominator. Very good. What is this first denominator factored? 2 and 4. X plus 2, x plus 4. You okay with that? And what's the second denominator factored? Remember, it has to multiply to be -6 and add to be -1. -3, +2. Does that make sense? Remember? Okay. So when I go to figure out what my common denominator is, do they share any common factors? X plus 2. So we know x plus 2 has to be part of the denominator, right? What else is there? X plus 4 and x minus 3. All of those have to be part of the common denominator as well. Okay? All right. What does this one lack? An x minus 3. So I'm going to multiply this by x minus 3. What does this one lack? X plus 4. I'm going to multiply this one by x plus 4. Okay? All right. X squared minus 3x plus 3x. What happens to that? Minus 3x plus 3x. That's just 0, right? And then minus 9. So I had x squared minus 3x plus 3x minus 9, and that part went to 0. Okay? Please understand, I didn't just square the first and square the second. That's not where that came from. I distributed and lost my middle term because it's 0. Okay? What happens here? Okay? So what do I end up with? $27? Yeah. Can I factor that one? Multiplies be 27, adds to be 9. No. So that's just my answer, right? Okay. Any questions? All right, on the back of this sheet are your 8 homework problems. 1, 2, 3, 4, 5, 6, 7, 8.